Turn it on.
Oh, there you go. Yeah, so my name's Lee. I just moved to Pittsburgh from Dallas, and in my lap is Lola. Lola says hi, and she needs to go back to sleep now. um, I'm going to talk to you about a project that I just jumped headlong into when I first got here. It's really cool. And uh, without further ado, let me switch to screen share. I think I'm screen. No, there we go. Okay, let me turn off video because my light is bright. Hold on. Oh well, I'm just gonna turn this light off. Okay. Um, Caves. We started our lives. We started our story started in caves as Homo sapiens, and to get to the moon, to build a home on the moon, surprisingly, caves have come up as one of the more innovative pitches for how do we inhabit the moon. And the reason for caves on the moon is simple because if you're on the surface of the moon, if you're sitting on top, you're getting pelted by micrometeorites, you're getting pelted by radiation. But if you're just 2 meters below the surface, you're protected from both. And in addition to that, you actually, let me turn my light on, hold on, point the other way. In addition to that, there's actually water on the moon, and scientists have already demonstrated that you can convert that water into oxygen or water to drink. So it's apparently really plentiful, and I think you can access it through the caves, and that's kind of what we're exploring. And feel free to stop me if you have any questions. So yeah, so caves on the moon, our best shot right now at building a habitation on the moon. That's the goal. So how do you get into a cave? Well, unfortunately on the moon, you don't just walk into it because everything that's on the surface has just been battered to dust. So there are these sinkholes, and the sinkholes aren't guaranteed to access these caves, but they have the potential to give us access to a cave. And in fact, these sinkholes, you can actually see, there's this one photo I wish I had. There's this string of sinkholes, which basically what happens, how they were created is there's a cave, and I don't know how the caves got created on the moon. I think there was volcanic activity before a long time ago, and so they're kind of lava tubes, but there's a cave that runs under, and the surface on top of the cave collapsed. And so you have these things called skylights where you could potentially have access to just a gigantic cave. So we're trying to figure that out. So how do you find out if a skylight, one of these collapsed holes in the moon, has access to a cave? Unfortunately, I wish you could just like bounce a satellite off or get satellite images and then process the images, and then you're like, oh, look, I can see right here. But the resolution on satellites is not there yet. In fact, I think the highest resolution of the moon is something like, I forget, it's like 10 meters by 10 meters for the surface. The resolution isn't there. And in addition to that, the problem is with these sinkholes, they're pitch black, so you can't see in them. So the plan is to get this little guy, this little robot here, drive him to the edge of one of these sinkholes and shoot a camera down into the sinkhole and take images and also bounce maybe LiDAR off of the opposite wall. What you can do with that is you can actually take the images and reconstruct a 3D model of that sinkhole. And then you'd be able to say, hey, look, this looks like an opening in the wall. I think we've spotted an opportunity to get into a cave here. So, and this is an example of structure from motion. And structure from motion, I just learned about it. You take images and it actually maps what's called a 3D point cloud. So computer vision has made it to the point where they can take a collection of images from, and actually they did this as a project. I think it was it was an Italian city. They took photos from the internet that people had taken, and they just collected them all together, and they were able to reconstruct the cityscape that all of these different photos from all of these different positions were capturing. And the way they do that is really cool. We have algorithms that are able to estimate distance, and then you've got the algorithms like the computer vision stuff that matches features together. And so, man, it's really cool. And it's all plug and play too. Like, you can have access, like anybody has access to this kind of software. You just literally go take a collection of pictures. And it took me like a couple days, and I had a full structure, like a 3D mesh model from a drone video. And that's just like, that's mind blowing to me that this technology is just floating out there. Anyway, so you've got these sinkholes on the moon. We want to put a robot on the moon and look inside the cave. We need to test before that. We need to figure out, and that's kind of their methodology here. It's rapidly prototype, rapidly test. Let's get to the next test. So what we're going to do is, this is a picture of a sinkhole in Utah. And this sinkhole is the closest analog to what we're trying to model. And it's really cool because we're flying out there next Friday, and we've created a prototype machine, and this machine's only goal, yes.
Yeah, hey, where did you say you're going?
It's called West Desert Sinkhole in Utah.
Oh, okay. And that's what your picture is here.
Yeah, this is the sinkhole. Like,
Gotcha.
Yeah. I did a test run on the second floor of the robotics, like this big industrial robotics room. And just pushing my cart, because I'll show you in a second, pushing this little robot to the edge of that, like, I don't know what you'd call it. It's a walkway, but it opens up. That was scary. So I don't want to even go anywhere near the edge of this sinkhole, which is the whole point. We want to get good ground truth data without risking anybody's life. So you can see, like, the little person down here, the scale of this thing is huge and intimidating. So I'm going to skip class for like 3 days to go play hooky and go do this. So I'm excited. Here's the sinkhole from above. I mean, this thing is a beast. And you can see, like, the top it's kind of sandy. So if you needed to get really good photos right on the edge, you don't want to be standing anywhere near there. You can drive a robot, but this one's like a version 1, like, prototype. So this is the PitCam. This is the first iteration of the camera that they've created, or the machine that they've created to take pictures from the edge of a cliff. And you can see there should be a really long handle here, because I'm not going anywhere near the edge of that cliff. But the whole point is, it's a robotic machine that it juts out over the edge of the cliff. So you roll it right up to the edge, you lock it in place. It juts out, so it pushes out, and then it's got 2 scissor lifts. And what these do, they just collapse and they lift. So the whole goal is to put it in different positions and just get a whole bunch of pictures at a whole bunch of orientations. If you look here, this is a pan tilt unit. And the pan tilt is the same machine that security cameras sit on top of. So if you've ever seen, or if you remember, if you've ever seen like the command center for a high-tech security place, you can actually control these cameras with like a joystick. So you can rotate them, you can point them down, you can point them up, you can basically look where you need to look using a joystick. That's what this does. We don't have a joystick, I had to code it. So moving on. Here's the thing that we actually built. And it's made of wood. It's a fairly simple robot. So compared to the other stuff. So like its job is fairly simple. Push up to the edge of a cliff, look a bunch of different ways, move to a bunch of different positions, and take really good photos looking down into this cliff. And that's what this does. So you've got like, you can see these little yellow striped tubes. Those are the motors. Those are the actuators. This thing has 3 actuators. So one is to drive forward and backwards, so push out over the edge of the cliff. And then you've got the 2 little scissor motors here, or actuators that drive these scissor lifts. And up front, this is the actual pan tilt unit. It's a pretty hefty, it's a good like 50-pound device. And this is our camera. This is a Prosilica. Prosilica is known for computer vision. So it's not a typical camera where it's simple to just like turn it on, take a picture. No, like you have to read through the SDK. It's fairly involved, but you can do some fairly advanced things with it. You can command exposure time programmatically. You can trigger, that's my dog. You can trigger photos using like a mechanical switch or some kind of electronic switch. But this thing is cool, and I'm going to show you a video of it in a second. This little guy right here is the pan tilt unit. This pan tilt unit measures the roll and pitch. When we push it out onto a cliff, it may be leaning down, and we're going to read from this and decide if our baseline camera view needs to be adjusted up. Basically, that's the whole point of this inertial measuring unit. So here's the high bay. This is what I was talking about. This is the second floor. This is the side view. The camera's looking away from us. So you can see it's sticking out over the high bay. And that's a pretty good drop. That's like a 30-foot drop. And I'm going to show you what it looks like while it's running, but that's the idea. It's not going to be this right now. It's on a cart. It's in progress. So it's not going to stay on a cart, obviously. We're going to actually build its own cart. Their methodology at the Robotics Institute is really cool. It's like, let's set a really ambitious goal. Let's build to that, and then let's test it. And then let's do it again. Let's set a really ambitious goal on a tight deadline. Let's see test results. There's that saying, trusting God, all others bring data. In this institute, it's all others bring video proof that your test run worked well. So if you have a video, that's currency here. Oh yeah, and so I'm gonna show you what it looks like. Let me see if I can grab this link. Yeah. This is footage of a test run. You hear that? That's there it goes. Yeah. That's the pan tilt unit rotating and doing its thing. It rotates and it points it up and down. And then, yeah, I just took that's my program outputting as it's running through the sequence. That's the basic idea. Let me go back. Oh, I guess that's it. Yeah. Any questions?
Yeah, so Lee, can you talk just a little bit about, I know you used ROS for some of your work. Did you use ROS on this project? And I don't know if you can share any screenshots or do anything like that while we're on the call, or if that's too much, but just talk about it if you can't.
Yeah, actually, yes. So when I got here, when I arrived at CMU, I've always wanted to, I knew they had a #1 robotics institute. I knew that they had #1 like artificial intelligence lab. So first day of class, there's this open call to join projects like these. And I volunteered to lead, but I didn't know any ROS. I've never programmed a robot. So boy, did I learn quickly. So I'm going to show you, I'll actually walk you through if you're actually interested. Let me show you. Yes, it uses ROS. It uses both packages in C++ and Python. So I had to be capable of at least reading both of them. I'm really good at coding in Python, but not so much. It's been a while for C++. I'm getting back into it, but the biggest challenge, the biggest challenge of this project was actually not necessarily, well, okay, getting the code to run was the second challenge. Like, really, the biggest challenge was getting code to talk to these industrial components. So you buy this like industrial pan tilt unit. If you have a question about it, Google is not going to know. It may know. Yeah. Yeah. This is very much like, this space is very much tribal knowledge in the sense, if you have a question about this pan tilt unit, what they told me is, hey, you need to go upstairs and talk to Srini. He's a PhD student who's worked with this pan tilt unit. It's not, you need to Google this and find out, because if you Google it, there's nothing. The topics in robotics are so niche, and especially if you get your own industrial component, you're on your own figuring it out. So you're in the manual, you're reading like true engineering diagrams. And thank God I had a PhD student who could just swoop down and fix any difficult problems I had, because he would just like clear that stuff out. But for me, that it would have taken 10 times as long. So I can walk you through the code. Let me show you the folder.
Yeah, at a high level, and I'll have to I'm not into ROS yet, so I'm going to have to let Matt and other folks ask the hard questions. But.
Oh, sure. Yeah. 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 So to answer your question, yes, ROS.
Yeah. Are you done with the code, or you still have more to go?
There's still more to go. I actually have, let me pull up my Trello board for it. I thought I had like 3 weeks, but it actually ships this next Monday, and I have all these things left to do. Because I was messing with the GUI.
That's my favorite topic. I want to see the GUI. I'll let you run through the code first.
Yeah. We had to ditch the GUI for time, but I'll show you it. Yeah, so there's a lot to do. I mean, primarily, the hardest parts are over. how do we get the software to talk to the components? How do we get the components working together? But there are a lot of loose ends. Like, we wanted to be able to input numbers in a flat text file versus over the terminal. We wanted to do this. We wanted just tiny little things that all add up to a nice, smooth product. So
Lee, is this teleop now? Will you go to the edge of the pit and then you'll either run it through joystick or through key controls?
this is all automated. Let me explain how we built it. We wanted to be able to like go to precise, repeatable positions. So we have little, what are called limit switches, where whenever the physical thing moves over the switch, it sets it off and it sends a signal to the control board. And what I had to code is I had to code all of these motors to safely go to position, read that switch, and stop. So to joystick it, we could actually, but you wouldn't get the precise, repeatable movements that we need for good data, I guess.
How do you pick your spots around the pit?
They're trying to get a full coverage. So this is a ground truth kind of thing.
Okay.
In an ideal world with unlimited time, they'd choose like take 360 degrees of the circle, cut it 18 times, which is a huge number of each location that you set up on the edge of the cliff takes 20 minutes to run. So you can see it adds up pretty quick. So they're just trying to get the whole picture. That's what they want. They're not concerned about data size. We are constrained by time though. And well, data size to a certain point.
On your ROS code, if you want to show, what was the funnest part to code up?
The funnest part to code, that's a great question. Let me see if I can find it. Let me think about that. Let's see. Actually, I'll show you. The funnest part to code was actually, let's see, rig. This stuff right here. Let me show you. See if I can find a switch. The funnest part to code was the motors. I've never coded in ROS. I've never driven a robot before. When you sit down to code these industrial components, they don't know the word stop. So you have a situation where you have to have your hand, you have to like, as soon as you hit compile and you execute something, while you're debugging your code and testing it, you have to have your hand on the kill switch. What's that?
I understand what you're saying.
Yeah, because I mean, like, this happened, I was like, my single goal that weekend was, please do not be that guy. I'm trying to, what's that?
Yeah, don't be that guy.
Yeah, because I'm trying to make a good impression. They know I'm new. Do not destroy this machine. And even though the guy who's supervising me, he's kind of like, you're going to break the machine. And I'm like, no, I am not. He's like, it's fine. Just, you're going to break it. It's going to happen. I'm like, no, I am not. It was really exciting because this thing, you know, I'd be watching it go and I'd be testing out, okay, I'm telling you, you need to stop when you hit this switch, and it wouldn't stop, and I'd hit that kill switch, And sure enough, I'd go in my code and an equals or a greater than sign would be flipped and it's a less than sign. So little mistakes like that really have consequences when you start coding industrial robots.
That's cool.
One of the more exciting moments too was when I got the very first component to move, the pan tilt unit. It dawned on me immediately when that thing started moving that if you had your hand anywhere near that thing, it would just break your fingers. And so I have a new respect for like industrial robots. And I know there's a story out there of a guy who was programming like this huge robotic arm, which rotated. And for some reason, he like didn't set the safeguard where it can't do full rotation and it just rotated. He was standing, debugging his code, and it was standing and just rotated right into him and took him through the wall. So I had that in mind.
Yeah. What was the hardest node to code up?
The hardest, that's a great question.
Hardest aspect of ROS?
C++ in general is challenging because I'm not very familiar with it. I would say, yeah, I would say C++ because I had to code in it, but it's been a while. I remember on this one thing, I spent like a day trying to get something to work and I was so close. And I brought it to that PhD student. It was in C++. And he changed like 4 characters and it worked. And I'm just like, dude, not cool.
So you're using a laptop for the brain on your robot?
Yes.
And then what is your low-level controller?
The low level is actually called a lab jack. You're talking about like the
Digital I/O to your motors
Yeah.
and sensors?
Yeah, so it's called a lab jack T7.
Okay.
And it looks like this. And it's just basically, it's really simple. It's got pins for input, pins for output. And you just have to, I can show you the code too. It's kind of cool. Where did it go? Pan tilt. There we go. Yeah, this one actually, let me see. Yeah, there we go. The PhD, this one actually wasn't even a ROS. So with industrial components, I'm sure you've experienced when you buy them, usually they have like a ROS package that you can install. And then you just install it and get it running.
Yep.
This one, he actually hard coded the pan tilt unit. He just directly, and that's something you can do. If you know how to interface directly with the device, you can just hard code your own API, basically. And actually, I can send, oh, you know what? Oh, shoot. I'll send you a zip file of the code so you guys can look at it if you're interested.
That's a cool project, Lee. It's going to be fun. So you head out to Utah next Monday?
Well, the drop dead date for the robot is next Monday. I head out next Friday. Yeah, it's exciting. It's a little crazy here though, so the amount of work that they have us doing in our program. Plus, this is like a full-time job outside of it, so I'm like stacking pressure. I am crazy. As soon as this is done and we're back, I'm taking a break. I probably put in like 30-hour weeks with this, and then 40-hour weeks with my program too. But it's so much fun too.
That's awesome, Lee. Thanks for the update today. We hopefully you can come back in a few weeks or whenever and give us another update.
Yeah, absolutely. I'd love to.
Yeah, I mean, I hope you can stick around for the second half, and then I see there's some other folks on here too today that updates too. So
Oh, okay, yeah.
yeah,
Yeah. Let's see them.
and you've got more too. I mean, we can go a few more minutes too.
Oh no, that's it. Basically, robot, edge of cliff, scary to code, scary to run in real life.
Yeah, that's great. Thanks, Lee. Thanks for joining us tonight. Appreciate it.
Yeah.
Thanks, Alan, for the suggestion.
That's awesome.
I'll send Alan a zip file of the code.
Okay.
Yeah, that's great. And then I'll forward it on to everybody.
Yeah.
We have any other updates on projects for tonight?
Well, I've been fighting with a concept. I mentioned a while back, I was trying to figure out how to get your computer to shut down correctly. So when you turn the power off, it shuts your Linux down first and then kills the power. And on one of the machines we had here, I said, what are you doing for power sequencing? And I got a dumb look. And I thought, oh, that's what you're doing for it. So I went and looked at it in that little power converter box that we use. That's the one from minibox.com. You hook it up to your vehicle battery, and then you've got the option. One of them's called automotive mode, where it's got a wire coming out that goes to your ignition switch. So when you get in and turn the car on, it starts up the power and powers up your computer. And then when you're done, you park your car and turn the key off. And it's smart. It's supposed to be smart enough to send a pulse out to your computer and tell it to shut down. And then sometime later, it just kills the power to everything. So that's supposed to take care of all that. So I started looking at this, and it turns out there's inside the box, which I don't have it open right now, but there's a 2-pin connector inside that's supposed to go to, they say it goes to the power button of your computer. So I went and looked at that, and they give you a little cable, a little 2-pin cable. It's got a red and a black wire on it. So I was looking to see, how do you know what polarity to hook it up? And I kept looking at it. They don't have it marked anywhere. And I looked at their documentation. They don't say anything about it. They just say it hooks up to your computer. So finally I went and put it under the microscope. It's a little tiny chip on the board. And this isn't the best way to do this, but here I finally decided it's probably one of these. It's a analog switch, and it looks like down here at the bottom they're showing it. Basically, it's kind of like having a solid state relay is what it turns out to be. So I think the 2 pins coming out are totally isolated from everything else. And that's kind of what I'm hoping at this point. Because if I take an ohm meter and check them from the 2 pins to either power or ground, it says it's open circuit. So I'm hoping that's going to work. Then on the other side, I've got this computer. It's got a NVIDIA TX2 in it. And they brought out 4 I/O pins on the side of the box. And there it just said that they're GPIOs and they're 3.3 volts. That's all they told me about that. So I had to go track down how you talk to those if you have an NVIDIA board. And it turns out that I decided I needed a pull-up, but they don't put 3.3 volts out anywhere. So after agonizing over that for a while, I thought I'll use another I/O pin and set it to an output, which would be 3.3 volts, and then tie from there a resistor to give me my pull-up. So I screwed around with that. So I'm at the point where I made up a custom cable after like spending an entire day playing with this stuff. I've got my custom cable here with a connector on one end to plug into the box, and then the 2-pin connector to plug into my power supply. And then I got to figure out how do I run scripts at startup. So I spent all day trying to figure that out, and I found they keep saying things. Well, back in the old days, they used a NIT, and then they used something else, and Ubuntu had something called Upstart, but now they're using something called System D. And they keep saying, well, these things are getting used, but you don't know if they're really being used. So I've played with a Raspberry Pi that has Ubuntu on it, trying to get that figured out. And I finally got it figured out where I could start up and run a script. Actually, I just running a shell script is what I was running. So I just have it every time it starts up, it just writes something to a file, just appends to a file. So no, that's working. And now I'm going to have to go back and figure out how to do shell script and say, go out and initialize the pin, read the pin. And if it gets changed, then I'll have to execute a shutdown command. So this has been really slow going, but I can see light at the end of the tunnel now. So that's what I've been playing around with. And the whole point is, because when you get to your machine, say you got a tractor and you go start your tractor up, during development stage, you just go out and you have a power switch, you turn it on, and then you hook up your laptop computer and you run all these scripts and launch files and everything. And at the end of the day, you say, okay, you go into the Linux command line, you run your shutdown command, wait for the computer to turn off, and you turn the power off. But on, what I'm going to call the consumer world, a farmer's going to walk out and turn the key on, and he expects it to power up and become an autonomous vehicle. And at the end of the day, he's going to turn the key off, and it's supposed to shut itself down. So that's what I'm trying to figure out, is how do you get that power sequencing to do all that. And I was going to come up with a fairly elaborate way for my stuff that I was doing. So I'd have to switch somewhere. It's either development mode or consumer mode. And then here, when I was suggesting all that, they said, "Oh, just make sure it sets the computer off okay when it goes down." So that's what we're going to do with that little power converter. So when they turn the power off to the power converter, it says, "Oh, it's time to shut down." It sends a pulse to the computer, and if you got your computer set up to understand it, it turns out that the push button on Ubuntu, if you push the button, I think by default it pops something up on the screen and says, "Oh, do you want to shut down or restart or do something else?" But there's a command you can type in that overrides that. So as soon as you hit the power button, it just automatically shuts the thing down. But unfortunately, they don't bring the power button out where you can get to it. I just have GPIO pins on this thing. So it's a matter of trying to figure out how to get around that. And I think I've got all the pieces now. I just got to figure out my last thing now, I think, is there are two last things. One thing is I got to figure out shell scripts and figure out how do I read the pin and decide how to act on it. And then it turns out on the NVIDIA, I have to run it as, I have to have root privilege in order to talk to these IO pins. But it turns out if I go to the command line, I say sudo and do the command, it doesn't work. But if I do a sudo -s, which puts me constantly as root, then it does work. And I have no idea why it's doing that either. So those are my two last problems, figuring those things out. And so I'll probably go back to playing with that tomorrow, and then I'll ask somebody smart, and they'll say, "Oh, you just got to do this." So hopefully that'll take care of that problem.
That's funny. When I first started using the Raspberry Pi, I thought it was weird. There's no like on off button, and how do you shut it down? And I was just constantly just killing the power and then booting it back up. And I was like, at some point I'm going to corrupt the SD card in there. That's what I thought, but I've never had a problem with it. And I was wondering, has anybody ever corrupted their SD card by just killing the power on
Yes.
on the Raspberry? Oh, you have? Okay. On a Raspberry Pi?
Yep.
Oh, wow.
I've heard other people say that too. They say, "Oh, well, I got it." And they say you can just turn the power off, and then a couple of weeks they come back and say, "Well, it's just it mysteriously crashes the file system, and they have to reload it again." And say, "Well, that's don't listen to these people. Say just turn the power off."
Okay.
It's like any computer with an operating system. You really should treat it well, because it'll come back to bite you when you don't want it to. And I was surprised here that they're doing a commercial product. They're using industrial devices, and they hadn't thought about what they're just letting people turn the power switch off. And I'm thinking, well, that's going to come back to bite them at the worst time, because if you get it down to the point where it only takes you, say, an hour to reload it from scratch, well, still, somebody in production isn't going to want to. Because at the best you could do it in an hour, if you really set this stuff up, but it's probably going to take them 2 or 3 days to reload the whole thing. And so you really should think about this before you start shipping products to people.
Yeah.
I'll bet that you could use a voltage divider on a I/O pin and tell when the ignition is on, or when the tractor is running, let's say.
Well, you can, but the problem is if you turn off, say, the key switch and you just killed power to your computer, it doesn't matter if you can tell if the power's off or not, because it just lost power. So you need some extra
you need
switching.
constant power. If you're just hooked up to the battery,
And that's what this converter does. It connects directly to the battery, and then it has this extra ignition sensing switch in it that does that for you. So it'll supply like 15 amps or something.
Why do you connect to the ignition switch?
Just so you know that somebody started the vehicle up.
You'll know.
It's made for a car, so you're supposed to put it in your car and run your car computer for running. If you're doing navigation or you're doing a stereo system or something. So basically, it's designed so you get in your car, you turn the key on, and it powers up, and then when you're done, you park it, turn it off, and it just takes care of itself.
So you want it powered on before you get the car started?
No. It's just the fact that you don't have to worry about it, period. You just get in your car, you turn the switch on, it powers up this thing, which powers up your computer. It comes up and does whatever it needs to do.
Yeah, I'm suggesting that you don't want it to come on when you turn on the key. You want to wait for the engine to come on.
You could do that, yeah. Now,
and for that, you don't need to connect to the ignition switch.
Yeah, well, this thing is smart enough. This module actually will run all the way down to 6 volts. We don't have to worry about the starter dragging it down and that kind of stuff. I suppose during the winter it probably would be. It gets down to 20 below and you go to start. It may drop enough to confuse it at that point.
Yep, I've got one of those for the mini. What is it? Mini ATX power supplies. I do like those. But if you're running a Raspberry Pi, there are simple ways to do it.
And other than that, I guess I'm not sure what else I was working. I didn't get much done last weekend, but I started whining around about the fact that I didn't have a cell modem card or cell SIM card after mine got put in the robot. And the answer was, well, you can just borrow my phone anytime you want. And that's great if I want to go out and drive around the building here at work, but on the weekend, if I want to go do something, it doesn't help. So I'm thinking I might take the 2 Swift Nav radios and bolt one on my robot and then take the other one and have it so I can plug it into a laptop. So I can just fire up the laptop to get DOT correction data and just broadcast it out, either in the parking lot here or out in my neighborhood at home. And then that'll take care of it. That'll get me back in business again. Because I was all ready to try this stuff out when I pulled the SIM card out and gave it to somebody else. So I'm down at the moment until I get that figured out.
Matt, I can go and add on to Jeff's comments about connectivity. So starting with the connectivity thing, at the moment, let's see, I better share something so you can see. Trust God and your wife, and everyone else brings data. That's the one I like. So I've been in the yard driving my lawn tractor around a little bit. At the moment, the issue du jour is getting stable angle data. Just a 3D printed part underneath there. You can't really see it as an angle sensor. There's a magnet. There's a Teensy processing that and sending that back to the Raspberry Pi. So that is more stable than my previous solution, but I am getting vibration out here. And so I'm not sure, Matt, whether I'm going to be able to stick with being out there over the axle or not. We'll see how that goes. At the same time,
yeah. Hey, Al, I had a quick question. This is measuring, what's this measuring? The steering angle?
It is, yeah. So effectively, there's the resolution on this is I think 12 bits, so 0 to 65,000, and the rotation. So assuming middle is about 32,000. I've got about 40,000 ticks on there, but I'm still not sure it's going to work out. But it sounds good on paper, but I think there's still going to be some challenges with that. But I always wanted to spend some time on these magnetic angle or magnetic rotation sensors, and so it's been fun, frustrating, painful learning process. But that's as far as I've gotten that. The other Hey, Al, on that vibration, is it the distance between where the magnet is and where the pickup is changing that gap? Or is it like left to right shifting, all around, I guess?
It's up and down. I mean, it's interesting. The motor, it hits some frequency, and it's like a low frequency. And as soon as it gets to that low frequency, and if the machine is sitting still and just idling, this thing will start to vibrate up and down.
Okay.
So we'll again, I'm not giving up on it, and I think it will always be useful to have a sensor out there. I'm just half thinking, though, that I'm going to have to put a sensor on the motor like the guys in Argentina did, because that seems to be an elegant solution as well. So in the midst of getting the angle sensor worked out, I don't know, am I causing feedback?
Walter? Is it coming in? Are you able to hear that, or is it like a little garbage?
It says talking Walter. I don't hear that noise.
Okay.
The other thing that I've been working on is getting my GPSs organized. So I have a different GPS than some others have used. There's a website out there by Deep South Robotics, a guy, first name Wayne, really a shout out to, because he's really been helpful. But anyway, he was at one point in time suggesting this ComNav unit, which I ended up getting a couple. And so I've been trying to make that work. They have really fast pickup time and seemingly a really stable RTK signal. So, I mean, the document that I'm sharing is just the instructions that I've written on how to get that organized. The modems or the radios are programmable, so you've got to put it into program mode and start sending it some signals. And with Jeff's help and Matt's help, I had written some instructions a while ago. I was going to complain about who wrote the instructions, but it was me. And I don't know, somewhere along the way I changed from a binary signal or a binary command to an analog command. So I've effectively got the GPS outputting these commands. The board has a USB signal or a USB port, which is pretty cool. So at the moment I'm outputting those messages. This is a screen print of outputting those messages. This is a screen print of what the actual plot looks like. If you look closely, I'll have to zoom in on that. That R 0.013 meters is the plots that it's picking up. So that's the radius. So 0.026 meters is, edge to edge. I think I did the math. It's a couple inches. So that's pretty cool. It's reading it into the OEM software. And so I've also got it to now input that into a ROS command, although there was a question I got about covariance, which I'm not too familiar with. But I was able to get it into ROS, which was cool. I was looking for this. I don't know, it's out there somewhere. Anyway, I'm able to get the GPS signal into ROS now, which is super cool. So the next step is making the rover mobile and getting the correction data from the base station to the rover, because I don't have access to online correction data. So I've got my own base, I'm planning on my own base station. So these are the instructions I've started on programming the 3DR radios to transmit the correction data. So simple radio, I get, 1,000 feet or 500 feet out of these radios. That will be good enough, certainly for me. And then back to, Jeff's comment about connectivity. Jeff likes to show his latest purchase from MPGA, I think. This is the latest purchase from Amazon. So this would be in the base station, transmitting a Wi-Fi signal and a SIM card. I'll take my SIM card out of my jetpack and put it in this thing. And so transmit Wi-Fi from there is the notion. Ideally, I'll be able to get rid of the SIC radios and transmit over Wi-Fi, but the OEM support out of China for my GPS units isn't quite fantastic, so I'm not sure if I'm going to be able to make that work. But my purchase, Jeff and others, is to do Wi-Fi with a Verizon SIM card plugged into this thing. So yeah, that's where I'm at. Oh yeah, this is my task list. So yeah, I sheared my steering bolt again. So I'm up to a 1/4 inch bolt in my steering shaft. Don't laugh. I hear laughter. Stop that. Some changes on the angle sensor, get my base station going. I bought a Pelican case from Harbor Freight to put my electronics in. So I want to remount my electronics in a Pelican case, make a cover for the front angle teensy. I got to start to weatherproof this thing so it can withstand the snow, because Matt's challenge was Matt said he was going to kick me out of the group if I don't put a snow blower on the front of this thing. So that's what I'm trying to avoid.
We gotta start working on the attachment, the broom attachment or something.
Yeah, it has to have a winter use case.
Yeah. Speaking
So,
of,
a fair few things going on, making a little bit of progress.
looks great, Al. You're almost ready for the A/B test.
Almost the illusionary A/B test with cross-track error tracking. Kyler knows all about that, I'm sure.
We've got some upgrades to the base station then to include the Peer Pursuit. Like you mentioned Deep South Robotics. Jeff posted a link from them in the Slack channel about their web-based planner. I was playing around with that just a little bit, just saw the video, but that's pretty neat. It's kind of cool.
Yeah, I think we should try to recruit him to come into the group. He's really a smart dude.
Yeah, I'd like to get maybe him to give us a talk about that planner, and he's outputting waypoints, but we could convert that and then bring that in. So pretty cool.
Yeah, but I mean, if you check out his site, he's a big fan of the U-Blox GPS units. So I mean, if anybody's looking for GPS units, I would definitely check out his posting. That's it for me.
Awesome.
Have fun in Shanghai or Macau. That's pretty cool. And let us know when the registration opens for Vegas ROSCON. That would be cool to put that on the agenda.
Definitely. You want to get that one, get your tickets early for that one next year. There also will be a live stream link. I can post that as soon as I locate that. Today, there's kind of a pre-workshop. A couple of the constructors here doing reinforced learning. There's one discussion about the ROS ecosystem, like the discourse and the answers.ros.org and the wiki. And they're kind of the question is, how do you guys feel about that, the way to communicate with the ROS ecosystem, or do you see any other methods or things that they should add to kind of engage people and get information out?
I find Stack Exchange more hands-on and usable personally. I mean, again, and I'm a hack when it comes to knowing how to do this stuff. The wiki is all technically probably absolutely accurate. It's just, how do I apply it is, it's the examples and the application and, putting it in context is a more rich experience for me personally. So YouTube videos of somebody who's actually making it work, or Stack Exchange where there's a dialogue around, here's my code and how do I make it work? That for me has been super, super helpful.
Good point. Good suggestion.
Or somebody could just come to my house and show me. That would be even better. Yeah. Rent a Ross guy.
Like at CMU, they're just everywhere, but you can never find them when you need them.
Murphy's Law of robotics. Any other project updates or comments for tonight? All right. We'll try to send you updates from the conference here, and hopefully it looks like some good suggestions or some good projects. That one tomorrow I posted in Slack. They have that race car simulation, and they're using the TEB planner and Pure Pursuit controller. And like Al was saying, it's neat to see these packages, but it's also great to see examples of the packages configured and working. And so I'm kind of excited about that. They posted their simulator with the packages working. So all of that software is out on GitHub, and they'll have a presentation here tomorrow morning. And if you can't catch it, I don't know what time it will be where you are, but in a few weeks the recordings will be out, and so we can see that. If there's no more for tonight, thanks for being here. Thanks, Lee, for your presentation, and good luck out in Utah testing your robot and collecting the data. Would love to hear how it went and any updates.
Sounds good.
You guys have a great night.
Thanks, guys.
Hey, Matt.